Hi everyone, in today's video we're going to talk more about hyperbolas, but this time we're going to write equations. We're going to use completing the square to do so. So very similar to circles and ellipses, except we know that a hyperbola equation will be in the form x squared over a squared minus y squared over b squared equals 1, or y squared over a squared minus x squared over b squared equals 1. So it's either the y is negative or the x is negative. So we need to account for that when looking at completing the square. So normally I would say group the x's, group the y's, and bring the y constant over, or bring the constant over. And that's fine, we're still going to do that. But you want to group the x's and y's such that the positive one comes first, then the negative one. So it looks like that I have a positive x squared, so I'm going to put that one first and then the negative 9y squared. If the y was positive, I would put the y first, then the x's. Okay, so just be careful about that. So let's put the x squareds first. So 4x squared minus 48x, and then we're going to put our y term. So we have minus 9y squared plus 72y. And then we're going to bring our constant over by subtracting the 144. So we're going to do the same thing like we've done in the other completing the squares. We're going to take out the leading coefficient of the x's. So I'm just going to take out a 4. So 4x squared divided by 4 is x squared. Negative 48 divided by 4 is 12x. And then with the 9's, because I have a negative, I'm going to take out a GCF of negative 9. And then I'm left with y squared minus 8y. Be careful with this minus here. You're doing a positive divided by this negative, which makes this in return negative. And then we have equals our negative 144. And now we have to complete the square. So we're going to leave some space to make a perfect square trinomial in the x's. We're going to leave some spaces with the y's. And we're going to make a perfect square trinomials with the y's. And we're going to make sure that we even it out on both sides. So remember, half of b. So I'll write it out on the side so you have it. The b value is negative 12 divided by 2 squared. Negative 12 divided by 2 is negative 6. Negative 6 squared is 36. So that's what's going to go there. The b term for the y's is negative 8. So we're going to do negative 8 divided by 2 squared, which is negative 4 squared, which is positive 16. But remember, since there's leading coefficients out here, we have to do a little multiplying. So 4 times 36 is going to go on that right side. And when you do 4 times 36, you get 144. And that goes on that spot. Then we have negative 9 times 16. Don't forget to multiply the negative. That will give you a negative 144. So we're adding whatever we multiplied by on the right side. It's okay that that's negative. And then we're going to finish completing the square. So remember, we're going to write it as 4 times something squared minus 9 times something squared equals a constant. And when you do negative 144 plus 144, that's going to cancel. Plus this negative 144 over here will actually be another negative 144. And when we do the middle terms here, it's always the half value, right? The negative 6 and the negative 4. So it's x minus 6 squared for the x's, and then it's y minus 4 for the y's. And then remember, to get the equation of an ellipse, it has to, a hyperbola, it has to be equal to 1. So we are going to divide all of these terms by negative 144 to do so. Negative 144. So by doing that, we obviously get 1 on the right side. And when I divide, we're going to divide these coefficients, so 4 by negative 144. And when you put that into the calculator, you're just going to get a simplified fraction of 36 on the bottom. So we can leave the negative, so it's negative x minus 6 squared over positive 36. And then over here, a negative times a negative is a positive. So this is positive. So when you do 9 divided by 144 and make a reduced fraction, you actually get 1 over 16. And then the y minus 4 would go here. Now, you should be noticing that there is something wrong with this equation. Now, I had said in the beginning that we want to make the positive one go first. And you know what? That's a good strategy, but it's because that this negative 144 that we wound up getting here, that we divide them, it actually switched it back. So now the x is the negative term and the y is the positive term. So in order to make it an ellipse cannot have this plus sign in the middle, right? The ellipse has to have the minus sign. So all I'm going to do is just a little bit of rearranging. I'm just going to write this with the y first. So y minus 4 squared over 16 minus x minus 6 squared over 36 equals a positive 1. And that is my equation. And that falls under the correct categories. We have a minus sign, and we have a y squared that comes first. We have an equal to 1. Everything's perfect here. So now that we have an equation, I'd like to graph this thing. So first things first, do we have a center, do we have a horizontal or vertical axis? Well, since the y squared comes first, we know that that must mean we have a vertical axis. Our center will be found by taking the x value first, so negate the negative 6. That'll give us positive 6. Negate the negative 4. That'll give us positive 4. That's our center. Remember that the a squared always comes first and the b squared always comes second. So the square root of 16 is 4 and the square root of 36 is 6. To find the coordinates of the c value, we're going to take c squared equals a squared plus b squared. A squared from the equation is 16. B squared from the equation is 36. So we can say 16 plus 36, and that gives us 52. And we take the square root of both sides. I don't think the square root of 2 can be simplified anymore, so we can actually just make that into a close decimal. That is approximately 7.211. So if we're asking what the c value is, it's just the square root of 52. That's fine. In order to find the vertices and the foci, we actually have to graph this. So let's put our center. Our center is the point 6, 4. So right here. We know this thing is opening vertically, with A being the distance from the center to one of the vertices. So A is 4. So we're going to go up 4, and we'll label this V1. And we're going to go down 4, which we'll label this V2. Our B value of 6 gives us our box value. So we're going to go 1, 2, 3, 4, 5, 6 to the left, and 6 to the right. And now I know this is off, so just do the best that you can and make your box. And we can write down our vertices. They're all at the 6th line. So this is 6, 0, and that one is 6, 8. So our vertices 6, 0, and 6, 8. Now our foci, counting from the center, we're going to go about 7. So if my center value is here at 4, we're going to go 1, 2, 3, 4, 5, 6, 7. So somewhere up here will be foci 1. Then we're going to go about down 7, 1, 2, 3, 4, 5, 6, 7 and a little bit. So it should be somewhere in between negative 3 and negative 4. That's foci 2. And we can create our asymptotes through the corners of the boxes. So my asymptotes will look like this. And like that. Again, hopefully you have more space on yours than I do on mine. Oh, actually, I can move this over a little bit. So these will be our asymptotes, and then we can connect our vertices going towards those asymptotes this way and this way. And that is my graph of my hyperbola. And then I think the last thing that we need to do is just calculate the coordinates of our foci. So just remember, the foci are all in line with this vertex. So the 6 is the x value for all of these points. So it's just that we're at 4, which is my height, and we're going up rad 52, and we're going down rad 52. So the x value can stay at 6, and the y value is just 4 plus rad 52. And to get the other one, it's 4 minus rad 52. Again, the x value stays, and it's the y value that's moving. So take a look at what we have here. Make sure you jot down any questions that you might have at this point, and we'll reconvene tomorrow in class. All right, have a good night.